Alright, this is a CCG4 Eval kit. And there's some quirks and features on this. So here's the DC jack, and next to the DC jack is a DC in. And this is producing 23 volts in, which then connects to here, which you get 23 volts in, as if you've got a power jack in both places. And this powers this circuitry, and one of them decides to power this guy. Now, if you turn on this 23 volts, so we'll get only on board 1. So they've got IDs on those boards. So only on board 1, the LED starts flashing. This is on, this is on, this is on. Both of these should now be set as outputs, so they should now be sources. The other way of running this eval kit is if you use DisplayPort. So you got these two display ports. These are display ins, and they will output the DisplayPort over USB C. They are display in, and output it over USB C. And when in the other case, when you've got USB here, so you plug a USB in. This is still an output, so it's outputting voltage to the USB. And you can access the data on the USB through here. And you can access data through the USB through here. So if you plug a phone or a USB-C USB port, the output will be here. So when both of these two are sourcing power, the voltage on the V-bus is on this pin, on this header, not on here. So this is only used in the consumer model, where this is sinking power. You don't have this DC jack in, this is sinking power, and the voltage appears here, and then it powers up the next guy. So right now, we should get 23 volts here. We should get very little volts, about 0.4 volts on this pin here. Now, if I plug this into a phone, it will say fast charging, 36 minutes until full. It's going this way at 9 volts, well, 9 volts, 1.6 amps, and it's pulling 700 milliamps on the power supply. That's good. It is fast charging on the phone, which is good. So this, if you drag down on the phone, it'll say fast charging. Okay, that's good. So that's working. Now, here's a unique quirk about this. So if I turn off the power supply, the board turns off, but then it turns back on. And you'll see the arrow on this guy will go this way. That means this phone, it also has a DRP, URL port, with a charge connected device, and it'll start powering up this board. And it's going to be powering it at 5 volts. Interestingly, this is fine to run at 5 volts, so that's good enough to turn on the lights. Even though the manual says you need at least 15 volts, it still seems to work. So you plug this in, this powers up this board, it also powers up this board. Now if you look at this DC in here, well actually, because we're now in the consumer model here, we should get 5 volts here on here, and that's what we do. So if I measure this, get 5.2 volts, which is great. So this is the same voltage on here that we see here. And on this pin, on these two pins, we shouldn't get any voltage. And we don't, which is good. This is on the input voltage. This is the output. Okay, so here's another quirk of this. So let's say you've decided to turn this back on. Okay. So we're now charging connected device. We turn on power supply. So we're now supplying the board with 23 volts here. And if we look at the input here, we'll see 23 volts here. We'll see 23 volts here. However, the phone has not switched. It will still say charge connected device and is still producing power this way, even though there is power here. Now if I tell it to not charge connected device, if I click on that, we'll try to switch the roll, and it couldn't switch. The only way to make it charge is to disconnect it, turn it on, and reconnect it. That is an interesting quirk of this. As I say, not charge a connected device, and then it's now pulling. Right, so it doesn't renegotiate. So when you put power into here, it doesn't renegotiate the power requirement. Here's another issue with this board. We've got this powered up with 24 volts, and we're plugging in a power bank into it. So ideally, we'd want a source to this power bank. When the power bank switches on, it draws no current. So this is an issue with this board. Eventually the arrow will flip after a minute. It will flip, and then this will be trying to source into the board. So when the DC jack is plugged in, it doesn't prioritize the fact that it needs to source power. It tries to sync power for some reason. So we're going to fix this in another video. We'll force it to be a source for both the phone and the power bank. Finally, one last thing. So on the DC jack, we're 23 volts in. It's actually connected directly to the power input header. So they're both connected together. So if you do a beep test between here and here, they're both connected. So this DC jack should be connected to the power input header, and then from the power input header, it should go to the PMIC chip. So these two are connected together. Then from the power input, it goes to the PMIC chip, and then from the PMIC, it will decide which voltage gets provided on the V bus. And we can see this in the schematics. In the schematics, we can see the DC in jack here. There's DC in jack, and there's the port. So the DC power and the power input header J12 and J1, they are connected together. Then they go to the PMIC chip, which is here, and the two lines they're talking about is VCell1 and VCell2. So based on this, it will decide what voltage to output on V bus. And so these two lines come from here, which is VCell1 and VCell2, and it will decide one of 4 different states, which will turn on various FETs and decide which output voltage gets turned on. So there's actually a correction here. So DC power, these two are connected, then PMIC, then V bus. And then if you decide to be in, and then provider consumer control, this is done in the FETs here. This is the voltage on the connector itself, the Type C connector. And this is the voltage on the power output connector. So when you're in consumer mode, this FET turns on to power up the other dev board. So in this case, if we're in consumer mode, the FET will turn on power to this connector here, which when connected to here turns on this board. That's all this does, is turn on power to the connector itself from the voltage on the V bus on here. And we can see Type C V bus is connected on the USB C connector. Do a search for it. There we go. Here. You can see it here on the Type C connector. There's Type C V bus. Now you might be wondering about this J11 header. Now this J11 header turns on the LED. Now the LED, if you look at the data sheet, it will say J11, focus, J11 connects SWDIO pin to the LED2. What does SWDIO pin do? This is connected to the programmer header, and is connected to only one side of this side. It's not connected to this side. That's why there's a header here where it doesn't do anything, because this bit it doesn't go to this bit. So the SWDIO from here doesn't go to here. It only goes to here. It's only connected. If you look here, SWDIO only goes to this connector and not this connector. So it goes to this programming header, which is used when programming, but otherwise the software just has it on a blank sketch. And if you look what else is used, it's not connected to DNL, so in theory you could know when you're turning off the consumer side. So if this guy is high, the consumer side's off, if you want to know that, but it's DNL, which means it's not connected. And you can see it's connected on the debug header and on here, but only connected to one of these boards. This board and not this board.